Hi, Vito. We're at the R&D forum. A lot of things going on, but today I'm so excited to talk to you about quantum computing.
Sure. Well, it's great to be here, and thank you, Ayaka. Yes, it's quite a big event. Actually, in the title of the event is quantum computing, so there's a lot going on at NTT and around the world around quantum computing.
I was so amazed to see how far the journey we have came for the quantum computing.
What's amazing is like you say, the progress that we've made, but also how we're differentiating ourselves as NTT in the world of quantum computing. We're focused on something called optical quantum computing, which is very different than the traditional quantum computing because we're using light and fiber optics and optical technologies to build the quantum computer of today and the future.
So what is optical quantum computing?
Well, traditional quantum computing is based on superconductive materials. And so what that means is that you have a very power-hungry, very large footprint for a quantum computer. So what we are doing is building our optical quantum computer based on photonics. And that changes the whole paradigm of quantum computing because now you can start to build quantum computers that operate in normal operating environments and don't require as much power. So NTT has a very strong history of optical communications technologies, and we're taking that and applying that to quantum computing to deliver the optical or the photonic quantum computer of the future.
So there's optical computing and then the traditional quantum computing.
Right.
So the optical quantum computing take over everything, or they're gonna coexist?
No, they'll coexist because the traditional quantum computing, which is based on superconducting, will continue to be developed, and it's been around and it is more mature, to be fair. However, going forward, there is another basis for building out optical quantum computers, and there are other companies doing this. We actually have an optical quantum computer exists today. We use a term called qubits to measure the power, and the current one is very small. It's about 100 qubits, and there are others that maybe are 1,000 qubits. Our goal is to get to 10,000 qubits in the next 2 years, and so we expect that by 2030, we are aiming to have a 1 million qubit optical quantum computer be commercially available.
2030 sounds very soon.
Yes, it is.
Exciting.
Yeah, but we're very excited about it. And just today, our CEO announced a major partnership with a company called OPTQC, which was spun out of the University of Tokyo. And they are a company that actually builds optical quantum computers. So we're partnering with them because they know how to build quantum optical computers, but we know optical technologies. So the combination of our skills and capabilities and theirs is really going to help accelerate the build out of an optical quantum computer. And we're very excited about it. It's very big news. Our CEO and their CEO are on stage today talking about it. And I think it's going to make a lot of news around the world.
Interesting. So what's next? What's the vision for NTT?
Well, this is a very important part of our strategy going forward because it's still connected to our core competencies around photonics and communications. And as part of NTT's vision, we're always focused on solving some of society's most challenging problems, whether it's around healthcare or food shortages or engineering or long-term elderly care. For example, when we get to over maybe, I think it was 100 million qubits, we can start solving for delivering specific drugs to individuals. And that requires a massive amount of computation. Or, as we know, AI is continuing to evolve from generative AI to artificial general intelligence. And that's also going to require a massive amount of computing. So an optical quantum computer uses way less electricity to solve some of these really complex problems.
So not just only the energy consumption, but the computing, the
actual power, which AI is going to need, and artificial general intelligence, which is the next, the thinking AI, the rational AI. That's going to need a lot of power, and traditional computers probably won't be able to deliver that kind of thing. So quantum computers will need to be used to do that. And so this is a perfect match of both of our AI capabilities, as well as our optical capabilities, and now our quantum computing capabilities all coming together. So I'm very excited for the future for NTT and quantum computing in general and how we can contribute to that.
That's very exciting. Thank you, Vito.
Thank you very much.